All right, let's talk about the graph of an exponential function. So we already spoke about what an exponential function is. It's where the exponent has a variable in it, unlike other functions that we've done where the base has the variable in it. So let's just go over some details about what an exponential function graph looks like. So an exponential function looks like a plane taking off or landing. So taking off if it is growth, landing if it is decay. On a runway without actually touching the runway. It flies through a specific anchor point. So this is really important. Which is not always the y-intercept, but it is the y-intercept of the basic exponential function, which is just y equals b to the x, b for basic. It's really b for base, but b for basic exponential functions, y equals b to the x. And then for the basic exponential functions, the y-intercept is 0, 1. So again, the anchor point is 0, 1 for basic exponential functions. The anchor point changes as we do transformations, and we're going to talk about that later on. If you make a table for any basic exponential function, there are 3 points you must graph. Okay? The anchor point, 1 point, and 1 point on each side. So usually really very simple. Let's talk about it. So here, these are all basic exponential functions. It is all b to the x. Now, x and then this is y, which is 3 to the x. So let's do 0 first. We're always going to do 0 first because 0 is the easiest one. Anything to the 0 power is 1. And then anything to the first power is itself, right? 3 to the first power is just 3. What about anything to the negative 1 power is its reciprocal, right? Remember with negative exponents, excuse me, it flips. So this is going to be 1 over 3. Same thing here. We have 5 to the 0 is 1, 5 to the first is 5, and then 5 to the negative 1 is 1 over 5. What about if it's negative? So technically speaking, right, unless there are parentheses here, this is technically 2 to the x, right? The x goes to the 2 only. And there is a negative in front of it. I know that sounds weird, but this is technically what's happening here. It is negative 2 to the x. And so we do 2 to the x first, and then we negate it. So 2 to the 0 power is 1, and then you negate it, which is negative 1. Then it's going to be 2 to the first is 2, so it's negative 2. And then 2 to the negative 1 is 1/2, so it's negative 1/2. Everything just got negated. That's it. And then 1/2, this is a base that is less than 1. So you'll see what happens a little bit different, but same process. 1/2 to the 0 power is 1, still 1. 1/2 to the first power is still itself, so it's 1/2. But what about 1/2 to the negative first power? Remember, anything to the negative 1 power is its reciprocal. What is the reciprocal of 1 over 2? It is just 2 over 1, which is 2. So you notice that it kind of looks the opposite of what y equals 2 to the x would look like, which is exactly what would happen, right? This is decreasing as x increases. This is increasing as x increases. So imagine what's happening. This is going to be exponential growth, and this is going to be exponential decay. So notice the pattern here, that whenever you have y equals b to the x, you have your anchor point, which is, again, your y-intercept of your basic exponential function, b to the x, which is 0, 1. All of them have 0, 1, unless it was the negative, right? And then you have negative 1, and then 1 over that, the reciprocal of b, and then 1b. All of them had 1b. And then negative 1, the reciprocal of b, and then your anchor point, which is 0, 1. Again, this was a special case because it had this negative here. So it still holds the rules, just everything got negated. So then what happens with the graph? Let's look at that. So we're basically going to take those tables and graph them. Exactly what we just did. So notice there's always going to be a domain and range, a horizontal asymptote, which we went over in class, and then I'm going to talk about the reflecting when it comes to this function right here. So let's graph them. So we said here that we have -1, 1/3, 0, 1, 1, 3. So -1, 1/3 is about there. 0, 1, 1, 1, 2, 3. There it is. And we already spoke about the horizontal asymptote, which for all basic functions, all basic exponential functions, it is at y equals 0. That is your horizontal asymptote of all basic exponential functions. And we are going like the airplane, and it goes up, and we missed the point. Let's try that again. There it is. I didn't really get it, but you got the point. So it's getting infinitely closer to 0, but it didn't quite hit it. Okay, same concept here. We have our horizontal asymptote at 0, at y equals 0, because it's still a basic exponential function. And our points are -1, 1/5, which is about there, 0, 1, 1, 2, 3, 4, 5. Now, notice the difference here. It still is riding along the asymptote, but notice the difference here. It grows at a quicker rate. When your base is bigger, it grows at a quicker rate. Okay? The bigger your base is, the quicker it grows, right? Because it's being multiplied by 5 now, not by 3, by 5. If it was being multiplied by 100, 100 squared is a lot bigger than 3 squared. So that's the reason. So again, your horizontal asymptote is at y equals 0. Put the y equals 0 asymptotes for these two. Now let's graph this. Now for this one, our points were -1, -1/2, 0, -1. All of them are negative because again we negated them. So it's going to be -1, -1/2, 0, -1, and 1, -2. And now we still have the horizontal asymptote of 0. But notice it looks the same. It's just flipped over the x-axis because this is a flip over the x-axis, the same way we already know that from other graph transformations we've done. And lastly, let's look at what happens with this. We have -1, 2, 0, 1, and 1, 1/2. So it was -1, 2, 0, 1 again, and this goes 1/2. So what happens here? What is happening? It is actually not exponential growth, but, exponential decay. And so it looks like that. Still that horizontal asymptote at y equals 0. So it is decaying. It is getting smaller and smaller as x gets bigger and bigger. And we will continue to go over these next class.